Okay, welcome to Chemistry 121 and our first Tegrity lecture together. This is Chapter 1 that we're starting in. And Chapter 1, you'll notice, is focused in on physical properties of substances. And where we start with that is the discussion of what's a solid, what's a liquid, and what's a gas. Now, you have lots of common sense experience with each of these substances. You have, for instance, car keys, right? When you hold onto your car keys, you can probably hear them jingling. I've got mine in front of me. You know that their volume doesn't change. You can try and squish them, but the volume doesn't change. And the shape of them is not dependent on whether I'm holding them or not. So the volume is defined, meaning it doesn't change, and the shape is defined, meaning it's independent of things that I do to it in terms of its container. Liquids, on the other hand, have defined volume again, but undefined shape. And anybody knows this who's ever spilled a cup of water all over the place, right? Because you have this same volume that's now out of the cup, which was defining the shape via the container, and now it's all over the floor. So same volume, very different shape. So liquids have defined volume, but undefined shape. Their shape is dependent on the shape of the container that they're in. Gases have both undefined shape and undefined volume. So if you have ever put compressed air into your tires, your car tires, you're using pressurized air to blow up your tires. We can compress and expand gases. So they have undefined shape and undefined volume. So where we're going today is basically to talk about things like physical properties and chemical properties and physical changes and chemical changes, and pretty much how we sort these solids and liquids and gases into smaller categories. And to sort of help you with this, we're going to do an exercise where we've got this liquid. A TSA inspector at an airport has confiscated 3 bottles of clear, colorless liquid from a passenger traveling to Hawaii and has asked you, as the chemical consultant, to determine the identity of each of the liquids. So the first thing you want to do is brainstorm some ideas of possible identities of the liquid. And how this is going to work pretty generally with Tegrity recordings here is I'm going to say, go ahead and do this, and then I'm expecting that you're going to pause and actually do it. Because if you don't, and you just go on to me going on to walk you through what I think and what the answers are, you aren't actually engaging in the learning experience, which means you're really selling yourself short. So go ahead and hit pause first and brainstorm those possible identities of liquids, and then hit play again on the recording, and you should come back and we'll talk about some 6 possibilities that I came up with. Okay, so now we're back. You've got some possible liquids hopefully listed. You may or may not have the same ones as I do, but that's okay. I've got water, hydrogen peroxide, vinegar, shampoo, contact lens solution, and vodka. All 6 different substances, all clear and colorless. So the first things that we want to think about with these, the first sort of level of classification, is whether these substances are pure substances, meaning they are one thing with one set of particular properties individual to that substance, and which are mixtures, which are actually 2 or more substances that have been physically combined. So go ahead and think for a moment about the 6 that you came up with, or use my 6. Which of them do you think are just one thing, and which do you think are 2 or more things physically combined? So go ahead and hit pause and do that. Okay? So, more information about how you know something's a pure substance versus how you know it's a mixture. And specifically in chemistry, what we're going to call those things. So a pure substance, like I said, was one thing with one set of chemical and physical properties. And there are 2 types of pure substances that we use in chemistry. Pretty much what people use in science in general. There's elements, which is one type of atom, and there are compounds, which are 2 or more types of atoms which are chemically combined. And so one way to think about this is an element is just one circle. Oh, my circle's not that great. So I can have a circle like that, or I could have a triangle, and so those would be different types of atoms, and thus also different types of elements. A compound, on the other hand, is 2 or more atoms chemically bound together to act as though they are one thing. So you can think about it as my circle element and my triangle element are actually attached. They're not separate from each other anymore. And so wherever circle goes, triangle goes. They're chemically bound together. Mixtures, on the other hand, are two or more pure substances that retain their own individual properties. So even though they're in close proximity and mixed together, they're still their own selves. Kind of like when you're sitting in a classroom. You've been mixed together and you're all contained in the classroom container, but you're still your individual self. These either could be homogeneous, meaning there's one visible phase, or heterogeneous, meaning there's two or more visible phases. So for instance, if you think about a glass of ice water, how many phases do you see? Well, you see the liquid in the cup and you see the solid ice in the cup. And if we change it and make it, say, some kind of soda, like let's say you have a glass of root beer, you've got your root beer liquid, you've got your solid ice cubes, and you have something else in there. You have gas bubbles. So you actually have three visible phases occurring just in a glass of root beer. So when we talk about mixtures, if we were talking about this root beer, we'd be saying, whoa, that's definitely heterogeneous. There are at least two visible phases visibly present that I can see with my eye. If it was homogeneous, I'd only be seeing one visible thing. So for instance, if I had that root beer and the ice had melted and all the carbonation had escaped because it had been sitting out at room temperature for a long time, then what would you see? Well, you'd just see one brown liquid. So it would just look like one visible phase. We also, when we talk about these properties, which really set identity, we sort these into two categories as well. You can either have a chemical property or a physical property. So physical properties are more commonly used because you can measure them without actually having to change the substance, which is nice if you only have a little bit of substance to work with. So if you think about it, different types of things that you can measure without changing the substance would be boiling points. You can boil water, and then you can collect the steam that you've made, and you can cool it back down, and what do you get? Liquid water. So it's reversible. Same with freezing, melting, subliming. Subliming, if you haven't heard of, is just a solid going directly to a gas. So any of those things can be measured, and they're all reversible processes, meaning we can turn around and undo what we did. I can melt what I froze, I can condense what I boiled, so on and so forth. You might also have thought, physical properties, these might be something like the color of something, or the taste of something, or the shape of something, or the odor of something. And you want to be careful about listing any of those things for a couple of different reasons. For one thing, in terms of shape, we want to be careful there because we just talked about the fact that gases and liquids, their shape is undefined. So if we're trying to define something, which is what a physical property does for us, and we say that it's shape, and yet shape changes depending on the container, then that's not really defining what we have. Color and taste and odor have another issue, which is that they're subjective, right? Something may smell really, really stinky to me, and you may think that it is just the bee's knees. Hopefully not, but it's a possibility. So there's some subjectivity there, and in science, when we're trying to classify something and identify it, we want to be as objective as possible so that whatever classification I make, I can rely on the fact that you'll make it as well. So key there with physical properties is that reversible process issue. Then we also have chemical properties. These are going to involve actual chemical reactions, which are going to change the identity of the substance by rearranging the atom organization. So for instance, back to my circle triangle compound, if it underwent a chemical reaction, and that's what that sideways arrow that I just drew is telling me, is it's undergoing a reaction, now I might make a circle plus a triangle. They're separated. Now I've got circle characteristics or properties, and I've got triangle characteristics and properties, which are different than when I had these guys together. So Examples of chemical properties would be things like digestion, combustion, rusting, etc. They're not reversible. The food you eat, once you've digested it, you don't want it back. Right? That's what the toilet's for. So let's go back and look at our list again. With the idea that we're going to identify, are these pure substances? And if they're a pure substance, are they an element or a compound? Or are they mixtures? And if they're a mixture, are they homogeneous or heterogeneous? So go ahead for a moment and think about what you might decide for each of those. So go ahead and hit pause. So what do you think they are? Well, none of them are elements. None of them are a single type of element. And how would you know that? Well, if you have your textbook handy, if you don't, go ahead and hit pause and go grab your textbook. If you open to the front cover, just the very front cover of the textbook, there's a list, and it says it's the periodic table of the elements. Nice, pretty colors there, lots of boxes and squares. We'll talk a lot about what information is in there. But for right now, that lists all of the elements that we know about. Right? They have names like hydrogen and nitrogen and carbon. None of them is called shampoo. So none of these are elements. Water is a compound, and the reason we know that is if you think about water, you probably already know that it has this formula, H2O. And if you think about that, what that's telling you is that you have an oxygen atom. I'm just going to make that my oxygen. And then we have 2 hydrogen atoms chemically bound to it. Now, how do we know that the hydrogen atoms are chemically bound to the oxygen? Well, if you think about it, if you boiled water for coffee this morning and you managed not to blow up your house, it kind of suggests that the properties of water are different than the properties of hydrogen or oxygen, which are both very combustible. So water is a pure substance, in this case. Is your tap water a pure substance? What do you think? Well, if you think about it, tap water has some stuff dissolved in it. What kind of stuff? Well, it might be bleach from your purification system of your water sanitation. For instance, if you live in the city of Everett, they put chlorine through the water to kill off any bacteria that you don't really want to be drinking. And there's dissolved salts because water came out of the ground where it was in contact with minerals and it absorbed them. And that's in fact why water has different tastes to you depending on where you live. If you've ever been to Los Angeles, you know that the water doesn't taste very good. So it has something to do with where the water's coming out of. But water by itself, not tap water here, but just pure water, is just a compound. There's nothing else in it. Just one type of molecule that has 2 H's and 1 O, and they're chemically combined. And we also know this because water, if you think about it, has one freezing point and one boiling point, right? Water freezes at 0 degrees and it boils at 100 degrees. So let's think about these other ones. Everything else, well, is a homogeneous mixture that can be separated into its individual components by physical and chemical properties. Now, if you happen to have vinegar in your home or hydrogen peroxide in your home or shampoo or contact lens solution or vodka, you can pull out that bottle of whatever it is and look at it on the ingredients, and it will tell you. For instance, hydrogen peroxide will tell you that it is, I think, 33% hydrogen peroxide, and the rest of it is water. So what that tells you is that if I took the hydrogen peroxide, part of it will have the properties of water, and part of it will have the properties of hydrogen peroxide, because I've mixed them together. So let's look at this list. Do you think we're looking at elements, compounds, or mixtures? And if it's a mixture, are we looking at a homogeneous mixture or a heterogeneous mixture? So go ahead, hit pause, run through this list, and decide what you think. And then we'll come back and do them together. Whoops, I need to go back. So ice water. You've got ice and you've got liquid water. Is that a mixture or is it a pure substance? Well, hopefully you picked up on the fact that ice is just the solid form of water, and liquid water is liquid water. So you're actually looking at a pure substance there. And specifically, it's a compound. My O here needs a little help. Copper tubing, on the other hand, is just copper. And if you look at your periodic table of the elements, you'll see that copper is listed as element Cu. It's just an element. So it's also a pure substance, but it's not a compound because it's just one type of atom. So it's an element. Air, on the other hand, you may know is composed of some nitrogen and some oxygen and some other stuff. There's some water in there, plus a whole bunch of other stuff. So what does that tell you? Well, it's a mixture. Is it a homogeneous mixture or a heterogeneous mixture? Well, when you look at air, what do you see? Do you see one phase, visible phase, or do you see two or more visible phases? You just see one. So this is a homogeneous mixture. $14-karat gold, any thoughts? 14-karat gold is actually some gold and then something else. But when you look at it, what do you see? Just one thing. So this is also a homogeneous mixture. Sugar, turns out, is probably C12H22O11. Your table sugar is sucrose. If we were talking about glucose, it would be C6H12O6. And if we think about that, about glucose specifically, C6H12O6, that's actually a compound that contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So sugar is a pure substance, and it is a compound because it contains 2 or more types of elements. Table salt has the formula NaCl. It melts and boils and does all kinds of things as a unit of Na and Cl. It is also a compound. A chocolate chip cookie, when you look at it, you see 2 visible phases, and just to check, we can see also that those 2 visible phases have different properties. So in a chocolate chip cookie, you've got the bread part of the cookie, and then you've also got the chocolate chip. And if you've put it into the oven, you know that that chocolate chip could melt, right? Versus the bread part of the cookie does not melt. So 2 different types of properties combined physically. And you know this because you can reach in and pick out the chocolate chips. So a chocolate chip cookie is actually going to be a heterogeneous mixture. Okay, so moving on. More examples that you can do. You can look at number 22 in your textbook and number 28 in your textbook. And when you do that, which hopefully you paused before you went on to the answers, but I forgot to tell you to pause, so maybe you didn't. You'll find that A is a homogeneous mixture, B is a pure substance, C is a pure substance, and D is a heterogeneous mixture. So go ahead and hit pause and do 28. And then when you're done thinking about it, come back and hit play again. All right, so we're back. And in number 28, A is a compound, but it's the only one we actually know because it's the only one where we see 2 or more things coming together to chemically combine to make it. B and C could be individual elements, or they could be compounds, or they could be a compound in an element. We run into the same problem with E, F, G, and D. They are all unclassified, meaning we don't have enough information to decide. And one more in your textbook, number 70. So go ahead and cover up those answers since it looks like I had those up in advance. Go ahead and do number 70, think about it, and then come back and check the answers here on the screen. And then there's some vocabulary that comes up in Chapter 1 that I just want to hit real briefly. my expectation is not only are you going to be watching this recording, which is pretty much what I would do in lecture, but that you're also going to be reading the textbook. If you just rely on the integrity recording or you just rely on reading the textbook, you're going to miss some of the material, because I'm going to lecture integrity on the high points, the most important points, the ones that I think students have the most difficulty on, with the expectation that some things you are going to be picking up out of the textbook reading. So this is one where it's just basically vocabulary and just familiarizing yourself with some of the terms. So diatomic means you have 2 atoms. If I had triatomic, it would mean 3. Tetra would be 4. Poly is just a generic term for many. A molecule is going to be 2 or more atoms chemically bonded together. It could be an element like H2. So for instance, with H2, what I might see is 2 circles bound together. Or a compound like sodium chloride, where I had my example earlier of my circle and my triangle chemically bound together to make a molecule. Heteroatomic means I've got 2 or more atoms of different type. So NaCl, for example, here, I have 2 atoms of different types. So that would definitely be heteroatomic. Homoatomic, on the other hand, would be 2 or more atoms of the same, and that would be my H2 example. That would be homoatomic. Chemical formulas, we've touched on this just briefly, but to come back and make sure that everybody's on the same page, these are going to list all the elements contained in the compound, or the element, and they're going to contain numerical subscripts identifying how many of each type of element. So H2O, like we talked about, has 2 H's. That's what that 2 down here is telling you, and 1 O. And notice we don't write a 1 for the O. It's implied. C6H14O4 has 6 carbons and 12 oxygens and 4 O's. Excuse me, 6 carbons, 12 hydrogens, sorry, and 4 oxygens. So the homework for Chapter 1, because at this point we have covered all of the content in Chapter 1. I know that's pretty quick. But remember, you're going to read the chapter as well, and you can listen to Integrity multiple times. All of your homework is going to be found at the end of each chapter in the text. So Chapter 1's homework problems start on page 16. And you'll notice that these problems are listed by section in the book for easy reference. So if you get stuck trying to do a problem, you can go back to that section in the textbook, find a sample problem that your author, Mr. Stoker, has done, walk yourself through it and his solution, and then come back to the problem that you were stuck on and see if that helps you out. The odd number answers are in the way back of your textbook. You can find them there. And the problems are paired so that each 2 problems addresses essentially the same concept. So for instance, problem number 1 and problem number 2 are essentially the same thing. So in terms of preparation and making sure that you understand Chapter 1 for the assessments that will be coming up, you'll want to do 1 through 76. Now, if you want to do all 76 problems, you're certainly welcome to do that. If you want to only do the odd ones because you have access to the answers there in the back, you can do that as well. If you want to pick 1 question out of each section just to double check that you sort of understand the concept, that's fine as well. I leave it entirely up to you. I recommend you at least do the odds so that you have the base knowledge and the breadth of knowledge that will help you to be successful on quizzes and exams. And I think, yep, that's it. So I'll see you later.